Hey guys, so here's the notes for 6.1. We're going to be talking about radicals and rational exponents. Okay, so we first will need to talk about how can we rewrite a radical into a rational exponent and vice versa. It is possible to do it. So basically a radical means it has our square root or it's a cube root or anything like that. That's what we call a radical, okay? So when we think about radical notation, we have the nth root. So that's what this n represents. I'm going to say nth root, okay? And then our a is what we call as our base. So we have the nth root of a. Now we could have that extended to a power. So like if we are going from radical notation to rational exponent, a would be our base, and then the 1 would be our exponent, and then the n is our root, okay? Now, we can always go from radical notation to rational exponent notation and vice versa. So let's look at rational exponent. So it says let a to the 1/nth be an nth root of a, okay? And then we're going to be n be a positive integer. So notice here we have a to the m divided by n power. So how we rewrite from a rational exponent to a radical notation is that your m is going to be the power or exponent. So you'll kind of hear me say like power or exponent and interchange those words, and they mean the same. Then your n is going to be representing your root on the radical. Now, how will you remember this? Well, think about this, right? Roots of a plant. Roots are underneath the ground. Well, we think of a fraction, and that's what rational exponents are, fractions. Well, the root is going to be underneath the fraction line, okay? So it's underneath. And then, of course, your a is going to be your base. So we look here at the radical notation. We have a as our base. We have m as our power / exponent. There we go. Do this instead. And then our n, that's going to be our root, okay? So we basically say nth root of a and then say to the m power. Now, using one of our exponent rules, when we have a negative exponent, remember, anytime we have a negative exponent, we need to move that value, okay? Because we can't leave our answer as a negative exponent. So if it's automatically a numerator, we put it in the denominator to make the exponent positive, and vice versa. If it's in the denominator, we move it to the numerator to make it positive, okay? So if this is the case, all you have to do is you put it either in the numerator or denominator, and then you rewrite it like we've done before, okay? Okay, so let's use this information to rewrite expressions in radical and rational exponent notation. Okay, so for example 1, we're going to rewrite the expression using radical notation. So this means that our a and b, for example 1, are already in rational exponent notation. So I'm going to go ahead and do that. Just place that so you guys know. So this is rational exponent notation. So then this will help us when we need to do example 2. So rational. Okay. So we need to rewrite it in that radical form. So what we need to identify is our base. So here our base for a is going to be 3. Okay. Then the 2 that is in that fraction, that's going to be our power or exponent. And then the 3 in the denominator of the fraction, that's going to be our root. So how we see that is going to be the cube root. So we have the cube root of 3, and I'm going to take that whole thing, and it'll be taken to the squared, or to the second power. Okay. Okay, let's try that then on part B. So 4 is going to be our base. The 1 is going to be our power. And then 6 is going to be our root. Okay. Now notice we do have a negative exponent on part B. So before I change it into that radical notation, I'm going to go ahead, because that 4 to the negative 1/6 is in the numerator, I'm going to bring it to the denominator, which allows us to make that exponent positive. Now I'm going to go ahead and rewrite. So 1 over, we're going to have the 6th root. So it is important to know how to say it. So all you have to do, now there's going to be a square root and cube root. So square means 2, cube means 3. Every other thing, you're going to basically just say the number, okay? So it's like 4th, that means 4, okay? 5th, that means 5. 6th, that means 6, okay? So that's why we call it an nth, so n and then th, root. And then that's all being taken to the first power. Now you can write that if you want to, but because it's just an exponent of 1, we assume if it's not there, that's what it means, okay? Now also just be careful how you write this. When we write our nth root, whatever number it is, that value is going to be what we call like a smaller font, okay? So it's not really saying 6 times 4 or 6 times the square root of 4. What this really shows is when we do the root, 6 is a small number, and it goes like this, okay? And then we have the number 4. So be careful on how you write it. I'm going to do the same thing here so you can definitely see that when we do the cube root, it's like inside that radical, and then we have 3, and then square, okay? So just be careful with that. Okay, let's look at example 2. We're going to rewrite the expression using rational exponent notation. So we are already in the radical notation form for a and b. We need to write it in the other form. So on example 2a, we have the cube root of 8. So remember, if you have a 3, that means cube, okay? So let's identify our base, the root, and the power. So our base here is going to be 8. Our root is going to be the 3. And though we don't see a power, that means the power is going to be 1. So how I'm going to rewrite this is I have 8 as my base. The power always goes on top for our fraction, and then our root goes in the denominator. So we have 8 to the 1/3 power. That's how we write it, okay? Okay, let's look at part B. So here, now you might see on that radical, we don't see a number. Well, remember that represents square. So what is square going to represent as a number? That is 2, okay? So square always represents 2. So if you need to write that down, you might need to. Okay. So notice that 18 is going to be our base. 5 is going to be our power or exponent. And then the square, which represents 2, that's going to be our root. So we have 18. So the number 5, since it's the power, goes on top of our fraction, so the numerator. And then 2, to represent the root, that goes in the denominator. So we have 18 to the 5/2. Okay, so now let's go ahead and do example 3. It says find the indicated real nth roots of a. So what this means is n is going to represent our root, and the a is going to represent our base. Okay, so this is saying we are taking the cube root of negative 216. We have cube root of negative 216. Now you might be wondering, well, how do we know what's the cube root of negative 216? Because we are going to evaluate this. Well, you can use your calculator to do this. I'm going to go ahead and show you how you can use your calculator. Okay, I'm using a graphing calculator, so it might be slightly different if you are using a scientific calculator. So to do a cube root, you actually have 2 ways of doing this. One, we could go to the math button. So that's going to be on that first column, and it's going to be like the 4th row. And on number 4, you'll see this 3 and then the radical parentheses. That is the cube root. So I'm going to go down to number 4, press enter. Now I'm going to go ahead and plug in negative 216. And then all you have to do is press enter. We get negative 6. That's going to be our answer. Now, let me show you a different way you can do this, okay? Here, if we wanted to do a different way, first, we would put the number 3. Then we would go to math, and number 5, this is if you don't have a square or cube root, which we'll go over that in the next example as well. So the x represents any nth root. So you press that, and that represents now cube root. And now I can do -2/16, and I get the same answer, okay? So we have -6 as our final answer. Now let's look at part B. We have n equals 4 and a equals 81. So our n here, that is our root, and then the a is the base. So we have what is called the fourth root. Remember, that's inside that radical there, and then 81 goes actually inside, okay? So once you get to do this, okay, what we will have to do with our calculator is we will need to put in the number 4 first, then go to math, and then you're going to have to do number 5, where it's like the x root, okay? Because that'll allow us to do the fourth root. Then I put 81 into there, and then press enter. We get 3. Okay, so that's the way that you can use your calculator to find roots, which that's going to come important when we are solving equations. Okay, make sure you guys watch part 2 of the 6.1 notes. We're going to be talking about how to evaluate expressions with and without a calculator.